Okay, so let's look at problem number 23. So we're going to look at, too big. Let's make that smaller. So we're going to look at holes, vertical asymptotes, horizontal asymptotes, and slant asymptotes. Look at x-intercepts, y-intercepts. So the first thing I want to do is let's factor. So this will be x and then x plus 3 on the top. On the bottom, this will be x plus 3x minus 2. So we do notice that there is a hole in our graph, right? So we know that there's going to be a hole at x is equal to -3. So what I want to do is I want to take that away and make a new equation. So this will just be x over x minus 2. So what we want to do is plug in everywhere you see an x, a -3. So -3 minus 2 gives you -3 over -5. So we have a hole at 3/5. Okay, so again, it doesn't exist at that point. What else do we know? What else is left in our denominator? So there will be a vertical asymptote at x is equal to 2. Since these are equal to each other, the horizontal asymptote will be y is equal to 1. Take your coefficients. There is no slant asymptote, so NA. X-intercepts, right? Set your equation equal. I'm going to set the new one equal to it since x plus 3 cannot be both a hole and an x-intercept. So it'll just be x over x minus 2. So x is equal to 0. So we have an x-intercept at 0, 0. If you think about it, we also have a y-intercept at 0, 0. So let's see kind of what this graph kind of looks like a little bit. So 1, 2, 3, 1, 2, 3. So here we go. Vertical asymptote at +2 and horizontal asymptote at 1. So here's -3 and 3/5. It's probably somewhere right about there. We have our x-intercept and y-intercept at that point. So we skip our hole, go through, and our graph kind of looks something like this. So I'm assuming our graph is going to be positive on that side, but let's just double check. So let's plug in a number larger than 2. So let's plug in a 3. So again, you can plug it in here, you can plug it into the new equation. Does not matter. So this will be 3 over 1. So let's just put it like this. Our equation will be 3, 3. So there's 3, there's 3. So again, our graph is going to look like this. One thing that we didn't do on previous problems is write our domain and range. Just for this one, let's go ahead and do that. So our domain would be -infinity to -3 because that's the first x value that doesn't work. Then it'll go from -3 to the next x value, which is a +2, and then 2 to infinity. Our range will start at -infinity. The first y value that doesn't work will be 3/5. Union that, 3/5 to a 1, and then 1 to infinity and beyond. Okay, so let's see what this graph actually looks like. So it'll look like that. So again, here is our x-intercept. We said that there was going to be a hole at -3. So notice that it says it's undefined. And we can kind of see, if I can get it, an open circle at that point. Over here, we said 3, 3. So let's see, where's 3? Oop, too small. Here we go, 3, 3. Roughly right about there. Can't get it. But we get the idea. Okay. Let's continue. Here's our next one. So this one's an interesting one. I like this one. So again, holes, VA, HA, SA. Yay. Okay. So first thing I'm going to do is I'm going to factor the numerator and denominator. Bam. So as I factor that, I realize that there is a hole. So there'll be a hole at -1 because there is a common factor. So cancel those off. you will just be left with x minus 1. So if I plug in a negative 1 into here, I get negative 1 minus 1, which gives me negative 2. Now, funny thing about this, notice that because I got rid of the denominator, there actually is no vertical asymptote. There is no horizontal asymptote either, so none. And really, there's no slant asymptote either. So even though this is one more than the other, you want to have something in your denominator to divide out. Because if I divide x plus 1 by x squared plus 0x minus 1, notice what happens. So I get an x, so this will just be an x squared plus x, subtract, which means it becomes negative, that becomes negative, and then those cancel off, negative x minus 1, so this will be a negative 1, so you're left with negative x minus 1, and notice that it goes in evenly, right? Every time we've been doing slant asymptotes, we've always had a remainder, so this is not really our slant asymptote. What's happening is this graph is really a line. So really you're graphing x minus 1 and all it has is a hole in it. Okay, so we can still find x-intercepts if we want to, right? So set that equal to 0. We'll get an x-intercept at 1, so 1 comma 0. Y-intercept will be at 0, negative 1, because again, that's your value. Okay, so I'm just going to show you this on Desmos really fast to what this is going to look like. It's just a little straight line. So here's your 0, negative 1. Here's your 1, 0. And then what was our hole? Our hole was negative 1, negative 2. So here is negative 1. And oops, I just keep missing it a little bit. There we go. And again, we can see our hole in our graph. So because we don't have a rational graph anymore, it just turns into a line. Okay. Moving on, let's try this guy. So again, holes in VA, SA, HA. I did those backwards, sorry. This can't be factored. So if it can't be factored, the x doesn't go into it, so we don't have a hole. Vertical asymptote, this will be at x is equal to 0. HA, 2 is greater than 1. Since we still have a denominator, it does not have a horizontal asymptote, so it does have a slant asymptote. So here's our first problem with the slant asymptote. So let's do long division. So 2x squared plus 0x plus 1. We multiply. So what do I have to multiply x by to get that? So this will be a 2x. So 2x squared. What's great is we just subtract 0x, so this will be plus 0. So really we don't actually need that guy, so 0x. And then just bring down the 1. So this is my remainder. We don't really care about the remainder. We just care about up here. So we have a slant asymptote at y is equal to 2x. All right, x-intercept. Okay, so we have an x-intercept, so 0 is equal to 2x squared plus 1, and all over x. So this will just be that guy. So we have negative 1 is equal to 2x squared, so negative 1 over 2 is equal to x squared. If I take the square root of a negative number, it'll be imaginary. So what does this mean? We do not have any x-intercepts. Y-intercept, okay? For the y-intercept, again, plug in a 0, so this will be a 0 plus 1 all over a 0. Notice that we're going to get 1 over 0, so again, we don't have any. That's great. Okay, so what does this kind of look like before we start graphing this? So vertical asymptote, that's going to be on this line. Let's go ahead and make some numbers here to the best of our ability. So vertical asymptote, bam, bam, just so we can see it. Slant asymptote will start at 0, 0, because that's our y-intercept, up 2 over 1. If I go down 2 over 1, so we're right about here. Okay, and make it up. Okay, so you do want to pick some numbers to the left and to the right of your vertical asymptote. So let's go ahead, and since we don't have an x-intercept, let me just see if I can expand this. a little bit. Okay, so let's plug in f of 1. So this will be 2 times 1 plus 1 all over 1. So 2 times 1 is 2. 2 plus 1 is 3. So we have a first point at 1, 3. We have, let's try negative 1. So this will be 2, again, times 1 plus 1 all over negative 1. So this will be negative 1, 3. So let's see. I don't think I'll be able to bring that back up, unfortunately. Shoot, that's okay. So we plot those points. Let's see what it looks like on Desmos. So here is our graph on our Desmos. So what I'm going to do is type in y is equal to 2x and show you, oops, with the dashed line. There we go. So we can kind of see that dashed line a little bit better right there. And then you can see our dashed line here. And so we said negative 1 and 3. So we would plot that number is not negative 1, 3. So there's negative 1, 3. So again, with slant asymptotes, I want you guys to kind of just have the general shape of what's happening. You're not going to know this number. You're not going to know the vertex of this graph unless you had a calculator. Okay, so again, rough estimate. So that means on this graph, I wouldn't have you find the range. I'd just have you find the domain. Okay, last example looks like this. So let's go ahead and factor that. So the denominator will turn into x plus 2 and x plus 1. So if there is a whole, what basically this means is that x plus 2 or x plus 1 has got to be a factor on that. So I'm just going to do quickly synthetic division. So let's try negative 1 first. So that'll be negative 2, that'll be 3. This will be a positive 3, this is a 1, this is a negative 1. Perfect, so I know that that worked. So I know that x plus 1 is a whole. And then I have 2x squared minus 3x plus 1. If we factored that real fast, so what two numbers multiply to a 2 and add to a negative 3, so negative 2, negative 1. So this will be negative 2x, negative 1. So let's go 2x and x, minus 1, minus 2. So this will be x minus 2 and 2x minus 1. Alright, so wholes, we have it at negative 1. So that's going to go away, that's going to go away. So we have x minus 2 times 2x minus 1 all over x plus 2. So let's plug that in. So this will be, what, negative 3 times negative 2. So times negative 3 all over positive 1. So that'll be a 9. So there's my whole. Vertical asymptote will be x is equal to negative 2. We do not have a horizontal asymptote, so no. And then slant asymptote, we do. So for slant asymptote, let's just do x plus 2, and then this will be the 2x squared minus 3x plus 1. So 2x, my bad. And then this will be 2x squared plus 4x. Subtract, negative 7x, so this will be negative 7. Again, it doesn't matter what the rest of the numbers are because we don't care that we don't care about what the remainder is. So y is equal to 2x minus 7. So we can find our x-intercepts, find our y-intercepts. I feel like we've done that a lot for all of our problems. So let's see what this graph would look like. So notice on this graph we don't actually see all of it yet, right? Which is okay. So I'm going to zoom out a little bit more. So I'm going to go ahead and put in our, so 2x minus 7. So 2x minus 7, and let's pop that guy up. So here our graph is kind of focusing on that. And then the other one was x is equal to negative 2. So x is equal to negative 2. Let's see what that looks like, dashed and green. So again, what you want to do is you want to plug in some points and find out kind of what's happening. Again, the domain is all real numbers except for negative 2.